Today we are going to study uniform probability distribution. Let's start. Let's see the basic information. What is meant by a uniform distribution? A continuous probability distribution is a uniform distribution and is related to the event which are equally likely to occur. It is defined by two parameters x and y, where x is a minimum value and y is a maximum value, and is generally denoted by u of x and y, or if the probability distribution or function or probability distribution of uniform distribution with a continuous random variable x is given by f of b is equal to 1 by x minus y, then it is denoted by u of x and y, where x and y are constant such that x is smaller than a and a is smaller than b y, and it is written as capital X or denoted by capital X. Then let's see the type of uniform distribution. There are two types of uniform distribution: discrete uniform distribution and continuous uniform distribution. First, in a statistics or a probability theory, the discrete uniform distribution is a statistical distribution where the probability of outcome is equal likely and with a finite value. For example, we can see a good example of a discrete uniform distribution will be the possible outcome of rolling a dice, six side dice. The possible values would be 1, 2, 3, 4, 5, or 6. In this case, such a 6 number has equal chances of appearing. Therefore, we can say that each time the 6 sides dice is thrown, then each side has a chance of coming on uppermost face is 1 by 2. So we can say it is a uniform discrete uniform distribution. And second, the continuous uniform distribution. Let's not not all the uniform distributions are discrete. Some are continuous. We can say that there are not every time finite number of outcomes. So also in a statistic distribution with a infinite number of equally kind are measurable values. Unlikely a distinct random variables, a continuous random variable can be take real values in a specified range. In statistics, we cannot sometimes in observation we cannot see the finite number of distribution or observation. So there are infinite number of distributions. So sometimes we can consider a finite block of observation and perform the calculation further on. So we can say that it is a continuous uniform distribution. Let's move forward. So we are going to see the calculations for continuous probability distribution. Then the uniform distribution is a continuous is a one of the simplest probability distribution in statistics, as we know everyone. It is a continuous distribution. This means that it is a takes the value within a specified range, as it is a distribution and it is continuous probability distribution. It takes place in a uh, proper range in a two intervals. So we will consider, for example, we will consider from 0 to 1 the probability density function for uniform distribution taking value in a range of variable a to b. Then f of a and b, or uniform distribution of a and b, is given by integration of 1 by a minus b in an interval, and a should be less than x and x should be less than b, then only it is possible. The condition, or this condition should be satisfied, then only this formula is applicable. Let's move forward. Then we are going to see the expected value of a uniform distribution. The expected value of a uniform a or b, the distribution is given by the average parameter a and b. Then or it we can see the expected value for the uniform distribution, the midpoint value or interval midpoint of the interval of a and b. So let's see the formula. E of x means expected value is given by the interval of b, interval of b, interval of a, x, and f of x into dx. Then we can simplify it. Then interval of b to a is equal interval of b to a, x divided by b minus a and into dx. Then we can by taking the integration of x upon b minus a, we can get it b minus a divided by 2. This is the formula for finding the expected value for the uniform distribution. Let's move forward. So let's see the mean. Then we are going to see the mean for the uniform distribution. The mean of a contribution information distribution between bounds of a and b has the simplest formula, that mean is equal to a plus b by 2. This is formula makes the larger amount of initiative since the scenes of all outcomes have a same chance of occurrence. The average outcome of a outcome be equal to average of a largest and the smallest possible value. One last note, the terms average, mean and expected value are interchangeable. You may ask in a terms of any of those words. Handle by them as continue means we can find the average, mean and expected value by interchanging the value and some changes in a formula. So we can find from one to another. Um, so let's move the forward. Let's see the mode. Let's consider a random variable experiment. X be a random variable following following a continuous uniform distribution. Then the mode of x is given by mode of x is belongs to interval of a and b. Then after this we will take the mode f of means mode of x in the interval of b to n and further on. Then let's see the median. From the definition of continuous random variable has a probability distribution function x, and the median is a non-zero value, means it has a unique median is a unique because it is not equal to 0. So from the definition of median we can find that f of x is equal to 1 by b minus a by taking the initiative of interval of a and b. So let's stop this.